Hello everyone, welcome back to Quadratic. So today's video will be focusing on this year's trial paper for Negeri Sembilan paper 1. For question 11, it focuses on the chapter Permutations and Combinations, and I feel like this question is the most difficult question in the entire paper, but it's okay, let's go through the question together. Alright, so here in this school, the students have prepared 7 performances, and we have 3 singing, 3 dancing, and 1 drama. So in total, there are 3 categories of performances. Alright, so for the explanation of the question, what I will do is for each category, I will represent it as one unknown. Okay, so for example, dancing, I'll put D, singing, I'll put S, drama, I'll put R. Alright, so now the committee needs to arrange the performances, but they have criteria. Alright, so the first one is it must start with dancing, so means the first performance must be D. And it says end with singing, so means the last performance must be S. Okay, and then this is the most crucial condition, which is the same category of performance cannot be arranged in consecutive sequences, right? So this means for the remaining 5 slots here, I cannot have performances which is the same category side by side. Okay, so means right, the second performance cannot be dancing again. It must be the drama or the singing. Same goes to the second last performance here. Since it's S, so the previous performance cannot be S again. Either it's the drama or the dancing. So to find the number of arrangements, let's think of one of the possibilities. Right? So let's say here we have D, and then it will be followed by S, then followed by D, and let's say for the 4th performance, I put R. Right, so the 5th performance, I'm not really sure already because here the previous is R, so it can be D or S. So let's go to the back. Right, so here we know that the last performance is S, so in front here should be D. Right, so in front here should be S. Okay, so this is the first possibility that we can think of, and let's think of another possibility. Okay, so same thing as well, S, D, and then followed by S, and let's say here I put R. Okay, and followed by D. So if you compare these two possibilities, the only difference is the placement of R. If you focus on the pattern for D and S, is the same. D, S, D, S, D, S. D, S, D, S, D, S. Alright, so we should bring our focus to figure out all of the possibilities that we can place the R. Right? So here, since we have 5 slots here, so means we have 5 possibilities that we can put the drama. Alright? So here for the blank spaces here, let's fill in the S and D performances. Right? Okay, so to find the number of arrangements, we can start off with R first. Here we have 5 ways to place the R, so we should start off by multiplying 5. Alright, and then let's focus on the the dancing performance. Okay, so if we focus on the first possibility, right, the first possibility here, we can place the drama at the 1st, the 4th, and the 6th performance. Right, so it is fixed there, but these 3 performances, they can switch between each other. Right, so here we should multiply 3 factorial because we have 3 performances here. Same goes to S as well. S is located at the 3rd, the 5th, and the 7th performance, but they can switch between each other. So we need to multiply another 3 factorial to get our answer, which is 180. For the next part, we have a quiz competition and consists of section A and B. So here it says that in section A there are 8 questions, in B there are n questions. Okay, so this one we are not sure. So here there's a condition, which is the students need to answer 5 questions from any section, but the number of questions from section A must be more than B. okay, must be more than b. So here they give us the total number of combinations and we need to find the value of n, which is the number of questions in section B. Okay, so for this kind of question, let's imagine that this 1316 is not given. Okay, let's imagine ourselves we are finding the number of combinations. So how are we going to do that? Okay, so here, if you look at this condition, there are a lot of possibilities, right? So what we can do is we can put them in a table and then we list out all the possibilities according to this condition. Okay, so here we have two sections A and B. Okay, I'll put it at their respective columns. Then we should put here the total number of questions in the section. Okay, which is 8 for A and for B. Okay, then we list out all the possibilities. So let's start off with section A. If we have 3 questions, then section B there will be 2 questions, right? Then we slowly add the questions in section A. So 3 to 2, then 4 to 1, and 5 to 0. Then we will stop here. Because here we can only answer 5 questions, so we should max at 5. Right? So now with these 3 possibilities, then we can figure out and to calculate the combinations. So usually is 8C3 because from 8 questions I choose 3 to solve, and NC2. N questions I choose 2 to solve, and I multiply them together. Same goes to the other possibilities as well. So if let's say n is given, so the only thing we need to do is just add these 3 values together to find the answer. But here the answer given is 1316 and we need to find the value of n. So what we can do is we add up all of these values together, then we equal to 1316. We form an equation to find the value of n. So now for the NC2, NC1 and NC0, I can use the formula given in the formula sheet to find the expression first and then we simplify from there, right? But for this NC0, you can just change it to 1. Okay, because if you try to put it in calculator, if you put any value on top here, 4, 5, 6 or any other number, the answer will always be 1. Okay, you can try it out, but the answer will always be 1. Okay, so now we just use the formula here, and if you look at here, there are a lot of factorials. Okay, so we need to have a way to simplify them. So one of the ways is we extend its expression. Okay, so we know that for n factorial it will be n multiplied with n minus 1, n minus 2, n minus 3, and so on. Right? So what we can do is for the n factorial here, we can take out the n and we can take out n minus 1, so it remains at n minus 2. Okay, for example, something like this. Okay, and why I stop at n minus 2 is because I can cross off with the denominator. Same goes with this one as well. For the n factorial, I can take out the n, but I stop at n minus 1 because I can cross off with the denominator. Okay, then I can simplify it and then we will find that it is a quadratic equation. So there are 2 ways to solve. Either we use factorization, or meaning using a calculator, or we can use the quadratic formula. Okay, so if we type these values into the calculator, you will see that it is integers or fractions. Okay, so we can use the normal factorization way. But if it's decimals, we need to use the quadratic formula, right? The b squared minus 4ac 1. Okay, but here we don't need lah. So here to simplify and find the 2 answers, it will be n equals to 6 and this negative value here. So n here cannot be negative, so we need to reject lah. Okay, so our answer would be n equals to 6. For question 12, we are focusing on probability distributions, and in part A, we are focusing on binomial distribution. Okay, so we have this distribution whereby the x follows binomial, with number of trials is 3, but we are not sure of the probability of success, right? And in this diagram, you can see that at the x-axis, we have all of the possibilities from 0 to 3, so in total there are 4. And on the y-axis, you can see that there are the probabilities. Okay, so for part 1, we need to express the probability if we get 2 and 3 in terms of k and m. So k and m, as you can see in this diagram, is the probabilities for 0 and 1, which is not the possibilities that we are trying to find. It's the opposite actually. So since it is the opposite, then if we want to find the probability, we should use the opposite way, which is we include all the probabilities of all the possibilities here, which is 1. Then I minus out when I get 0 and minus out when I get 1. Okay, in this way. So then I substitute the px equals to 0 with k and this one with m. And this would be our answer. For part 2, we are finding the value of p, which is the probability of success, right? So if we look at this diagram, the only possibilities that have the probability is 2 and 3. As you can see, the probability is 1 over 64. Okay, so maybe we can use this relation and then we use this formula to help us find the value of p. Okay, but which possibility should I choose? Should I choose 2 or should I choose 3? So what I'll suggest is to choose the possibility that is most extreme, which here means 3. So extreme meaning in the experiment, either I get all correct or all wrong, instead of half correct, half wrong, something like that. Reason is because if we go through the working, you will see that some of the parts, if we have number there, it will be much complicated to solve. Okay, so let me substitute the r with 3 first and the probability with 1 over 64 first, okay, so that you'll see. So NCR will be 3C3 because N and R in this case is the same. P will remain as P, the power will put 3. This is the part where I want to explain. So this Q will be 1 minus P because failure would be 1 minus the probability of success. Okay, and then this power, because N and R is the same, the number of trials and number of success is the same, so this will become 0. So if this becomes 0, it will be much easier because this value will change to 1. If let's say, imagine this 1 minus P, right? And let's say I choose 2. So here will be 3 minus 2. So I still have this 1 minus P here. And I need to find some ways to remove it, to simplify it. Okay, but in this case, we already changed it to 0. And we can straight away change it to 1. Okay, so a lot of steps is prevented. Okay, so you don't have to do this part when you choose 3. Okay, so here we simplified the left side. So this 3C3 will also be 1 and this part will also be 1. So left side only left with P to the power of 3. And then we move the 3 to the other side. So your final answer for P is 1 over 4. For the next part, we are focusing on normal distributions. As you can see here, this x follows n. So n here refers to the normal distribution, and we have two parameters, which is the mean, which is 15, but we don't have the standard deviation, which is the sigma here. Okay? And we are given this statement, which is the probability where x is greater than or equal to 8. The probability is 0.6844. Okay, so now we need to find the value of sigma. So for any kind of normal distribution questions, I will always use this 5S method to solve. Right? So the first S is the statement. We need to write out our statement to start off with our working to find sigma. Right? So here we are given this statement, so why not we just use this to start off. Alright? Then the second S is to search. Search meaning searching the parameters, which is here, given here. Then the third S is to standardize. So standardize means from the X here, I need to change it to Z. So Z here is normal distribution with mean of 0 and standard deviation with 1. So to change from X to Z, we need to use this formula. So X minus the mu, which is the mean, divided by the sigma. Okay, so our X here is 8, and we need to minus with the mean, which is 15, and the sigma we don't know, so we can just remain. Okay, and then we simplify. Then the fourth S is to sketch. Sketch meaning according to our statement here, and we need to use this probability distribution graph to sketch out our area. Okay, so there are two things to look at. The first one is the inequality. Okay, the inequality here. So this is greater than or equal to, and if we imagine this as an arrow, it actually tells us to sketch to the right side. Okay, so from this graph, we need to sketch to the right side. And how much should we cover depends on the value here, which is the second thing we need to look at. Okay, so this value, if we convert it into percentage, means 68%. So 68% means we need to draw more than half of the graph. Okay, so since we need to draw more than half, means that we need to sketch starting from the left side, right? Because we are sketching to the right and we need to cover more than half of the graph. So we can assume that this value, -7 over sigma, is around here, and then we sketch to the right side to satisfy these two criteria. And for the last S is the most crucial one, which is to select. So select means we are going to select the values from the probability distribution tables that we will see later, right, according to our sketched graph here. Okay, but our graph, or the area that we have sketched, we need to satisfy these two criteria first, which is the area must be one side only, and it must be sketched from the right. So according to our area here, we only satisfy the second criteria, because this area, we can sketch it from the right. But the issue is, it is two-sided. Left side and right side both are sketched. Okay, so how can we change a two-side area to become just one side? Right. So one of the way is, instead of focusing on this area here, why not we focus on the area that we don't want, which is here. Because as you can see, it's only one-sided, only on the left. So if we use this green color part, we have satisfied the first criteria. But at the same time, we didn't satisfy the second criteria. It's not from the right, but it's from the left. Okay, so the way to solve this is, because this graph is symmetric. Symmetric meaning left side and right side have the same shape. So what we can do is, for this green part here, from the left, we can move it to the right. Again, because this graph is symmetric, left side and right side have the same shape. So same shape means same area. Alright? But the only thing that we need to change is the value here. From negative, we need to change it to positive, because we move sides already from left to right. Okay, so now with this graph here, then we can write out a new statement. Okay, so here as we can see, we are sketching to the right side, so our sign would be greater than or equal to, right? So here should be Z greater than or equal to the value here. And for the probability part, because previously we are focusing on the orange part, which is 0.6844, and now we are focusing on the opposite side. So what we can do is, we look at the area for the whole graph, which is 1, minus out the orange part, which is 0.6844. Then we will get the new area, which is 0.3156. So from this graph, we have satisfied both criteria, so we can go to the tables to find our Z value. Alright, so our probability is 0.3156. So for the first step to find Z is to find the first value which is larger than the number here. Okay, so if we examine all the values here, you can see that there is one value which is exactly the same as the one we want to find. Okay, so we can just choose this value. Alright, so if now this value and the value that we want to find is exactly the same, then we don't need to minus anything from these values here. Okay, because it's exactly the same as what we want to find. Okay, so this second step we can just skip, and we can just jump into finding the exact values part from section A, B and C. So from A it would be 0.4, B would be 8, C would be no values. Okay, because we don't need to minus anything, so our exact values would be 0.480. So here we can write according to the tables, and with this result here, then we can compare the 0.48 with the 7 over sigma here to find the value of sigma, which is 14.583. First question in section B focuses on coordinate geometry. Here we have a rectangle and we need to show this equation, y equals to x plus 12. So if we look closely to the diagram here, you will see that point B and C have the coordinates, but A does have the coordinates, it's just that it is xy. So it should be the xy here. Okay, so we need to figure out a clue from these 3 points. Okay, so by focusing on the points, let's focus, besides focusing on the points, let's focus on the lines from these 3 points. Okay, line AB and line BC. So we know from rectangles, all of these angles, right, are all 90 degrees. So this means that these 2 lines that we are focusing on are perpendicular to each other. So this is the clue, right? 2 lines are perpendicular to each other because the angle is 90. So since it is using perpendicular concept, so we can use the formula that we have learned previously. Okay, so now let's calculate the gradients for both lines. So for the first gradient, I will use the red line. So assuming that this is the first point, so y1 minus y2, so 8 minus y, then x1 minus x2, which is minus 4 minus x. Then for the second line, which is the blue line, and assuming that this is the point, the first point, so y1 minus y2, negative 2 minus negative 8, x1 minus x2, so 6 minus minus 4. Alright, so now we can simplify the blue color part first because all of these are values. Okay, then the negative 1 I move to the right side, so here will become 1, and then I move this negative 4 negative x to the right side. Okay, now if you simplify and using remaining y on the left side, you can see that we have shown the result that is required. For part B, we need to find the area of triangle ABC. Okay, so here take note, yeah, it's not the area of ABCD, it's the area of this triangle ABC. Okay, and for our answer, we need to write it in terms of x and y because the coordinates of A we have not found yet. Okay, so to find area, we can use the shoelace formula. So shoelace formula is just cross multiplying the coordinates, then to find the area. Okay, but for shoelace formula, there are 2 ways. Okay, so one way is when we are trying to put the coordinates, we can use the anti-clockwise way or the clockwise way. So I will always recommend to use the anti-clockwise way because the value that you will calculate out will be positive. If clockwise is negative, which I think will complicate things sometimes. So I will always recommend students to use the anti-clockwise way because the answer you will get is positive. Alright, so to use the shoelace formula, let's start off with multiplying 1 over 2, which I think a lot of students will forget, so please remember this. Okay, then we put a modulus here, then we start off with the point A first, right? So point A, which is xy, then by going anti-clockwise, we are going to point C, which is 6 minus 2, and we're going to point B, which is negative 4, 8, then go back to the original point, which is xy. Then we close off the modulus. Right, so now it's just cross multiplying. So here x multiply with minus 2, 6 multiply with 8, then these values will need to minus off with the other cross multiplied numbers. So 6 multiply with y, negative 4 multiply with negative 2, and 8 multiply with x. So we need to minus off with these values. So I would recommend students to always write this out, even though it's a bit long, but it helps you to secure your marks. Alright? So once you simplify, and then if we move this 1 over 2 inside, okay, because it's multiplied, so you can move it into inside here, and all of these values here will be divided by 2. So this would be your final answer. And for the modulus here, please don't take out, because we are going to use it in part C, where we need to find the coordinates of A, and the area of the rectangle is 120 units. So this rectangle, as you can see, it's made up by two similar triangles actually. So if we just want to have one triangle's area, so we can just divide this value with 2, so it's 60. And since it is 60, we can equate it with the answer that we have got in part B. Okay, so we can form an equation first. But here we need to find the values of x and y, so meaning we need to find the value of two unknowns. So if two unknowns, we need to have two equations. So the other equation, we can use it in part A, which is the equation that we have shown just now. Okay, so later on, we need to substitute with each other to find x and y. Okay, but one of the issues is this modulus. We need to get rid of the modulus, and we need to move it to the other side, right? So when we move to the other side, we will always bring positive and negative to the other side. Okay, so now we will have two answers already. Are we taking 60 or are we taking minus 60? So this is where this part is useful, right? Because we use the anti-clockwise way, which we know that the final answer will be positive, so we should take the positive value, which is 60. Okay, so if let's say you use the clockwise way to calculate the area, so you should use negative 60 for your remaining workings. But here, since we are using anti-clockwise, so we should use 60. Okay, positive 60. So now with the modulus being moved, so we can just straight substitute this equation into the y here. Right, so here will be x plus 12, and then we simplify, find the value of x, substitute back to one of the equations, find the value of y, then we can get our coordinates, which is negative 10, 2. Question 14 focuses on quadratic equations, and sorry about the blur screenshot here, let me go through the question with you all, okay? So given the quadratic equation ax squared plus bx plus c equals to 0, okay, so this is the general quadratic equation that we have seen a lot of times, alright? And here it says that a, b, and c are constants, meaning they are numbers, right? And here it says a cannot be 0. And it says by using the method of completing the square, we need to form a formula of this. Okay, so this one I think you all are very familiar with it. This is actually the quadratic formula. Alright, so this question tells us to prove this quadratic formula using completing the square method. Alright, so why completing the square? I have mentioned this in my previous video. I can put the link here to let you all refer, but basically is this quadratic formula is actually the shortcut of completing the square. Okay, so now what we need to do is use the completing the square to prove this formula out, to prove this shortcut. Alright, so to prove, our main goal is using this general equation as our starting point, And at the end, we need to make sure that x is on the left. So means we are finding the value of x. Okay, so let's start off with this equation and let's use the 3 main steps in completing the square method to find the value of x. Right, so the first step is to factorize, or other ways as well, but making sure that the value of x squared must be 1. Right, so means the value here we need to remove, the a we need to remove. So one of the ways to remove is I can divide the whole equation with a. So you can see that the x squared value has become 1. And another way is, for the values that have x, we need to factorize a out. So this means I take the a out of the x squared, and for the x I also need to take out. So here what we can do is we divide with a. Because outside we are like multiplying, so here we do divide. So when you multiply this a back, it cancels off to become bx. Okay, but here we need to factorize a out for both x values. Okay, and then the things at the back, we don't need to change anything. So this one is factorizing the a out. But this one I feel is a bit complex, so I recommend this way. For the second step, we need to divide and square, right? So this means we need to take the value from x, which is b over a, and we need to do 2 things. Divide 2 and square. Alright? Divide 2 and square. So here when we add this thing, we need to have a counter effect. Because when we add stuff, we need to minus stuff as well. So what we can do is we minus the exact value. Okay, and then the things at the back we remain. So this is the second step. The last step, which is to combine. So combine means for the first 3 values here, for those which have square, this one and this one, we can combine their values, right? So this means the x here I can put here, the b over a over 2 here I can simplify and it become b over 2a, and I square them. Okay, so means these 3 values has become this value here. Alright, and the things at the back here, we just simplify. So the square here, we will square the whole thing, so it will become b squared over 4a squared. Right, the negative will remain as negative because it is outside of the bracket. Alright, so now back to our aim. We need to make sure that x is on the left. So everything which is not x, we need to move it to the right side. Okay, so we can start off with moving these 2 fractions first, but what I want to do here is to make sure that the denominators is the same. Okay, so one is 4a squared and one is a. So what we can do is, for this fraction, we multiply 4a. Okay, so the denominator will become the same. Right, so here will become 4ac, here will become 4a squared. Okay, then we move to the right side and we combine the values. So here it's negative b squared, so when I move to the right side it will become positive, and this one positive 4ac, move to the right side will become negative 4ac, and then I combine these 2 fractions together. Then later on the square, I can move it to the right side, but making sure we need to write out the plus and minus. Okay, and then here, for the things inside this square root, some can be simplified, some cannot. So for example, the b squared negative 4ac, we cannot simplify anymore, right? But for the things at the denominator, we can do, because square root 4 is 2, and a squared, when we square root, it's a, because the square and the square root, they can cancel off. So here will remain as 2a. Alright, so on the left we still have this b over 2a, so we also move it to the right side, but as you can see the denominators is the same, so we can combine these 2 fractions as well. So b moves to the right side, here will become negative, and here as you can see we have proved the quadratic formula. For part B, it says, hence, given this quadratic equation, we need to express the roots of this quadratic equation in terms of k. Right, so roots meaning we are finding the value of x for this equation. And also here it says hence, so this means we can use the quadratic formula that we have proved just now to find the roots. Okay, so here we just need to identify the value of a, b, and c. Okay, so let's look at x squared. So the value of x squared here is 1, so a is 1. The value of x here is negative 2k, so b is negative 2k, and c here is the values that don't have x, so which is 2 minus k. So now we just plug all these values inside this formula, and then we simplify. And for the 2, I will divide with the 2k and also the values inside the square root. Right? So inside this square root, how do we divide by 2 is, I can change the 2 to become the square root value, okay, which is 4. Right? Because square root 4 is 2. Then this 4, I can divide with the things inside. Right? So when you divide, it will be something like this. And this would be our answer. Right, last part. Part C is if this quadratic equation in part B has real roots, okay, real roots, we need to find the range of values of k using the number line method. Right, so here there are two main points. So one is the roots are real roots and we need to use the number line method. Right, so let's start off with the real roots first. So we know that for real roots, we need to use the discriminant, right, which is b squared minus 4ac. But for real roots, it's not more than 0, it's not equal to 0, and it's not less than 0. It's actually combining these two conditions together. So it should be greater than or equal to 0. Because these two, if our equation, the roots are more than 0 or equal to 0, there will be answers, right? This one, we have two answers. This one, we have one answer. So real root means the quadratic equation that has answers. So we need to combine these two to form the equation. Okay, so here we should start off with b squared minus 4ac more than or equal to 0. Right, so how do we find this b squared minus 4ac? Okay, we can actually plug the values here. Okay, but this b squared negative 4ac actually we have calculated in part B. Because as you can see, the things inside the square root is actually b squared minus 4ac. So what we can do is use the things in the square root. Okay, so our b squared minus 4ac would be this k squared plus k minus 2. Alright, and then this is a quadratic equation, so we can use the factorization method to split it into two answers. Alright, so now we need to use this number line method. Okay, so how do we do this? So first off, right, draw a line, okay, and then we split it into three parts. So how do we split is looking at the values of k that we have. So here the value of k is 1 and the value of k here is minus 2. So here I would put negative 2 here and 1 here. So from small to big. Okay? Then for each of the range here, I can determine a certain range of values already. So for this one, it's all the values which is less than minus 2. Right? Here will be the values is between negative 2 and 1. Then here will be the values which is more than 1. Right? So for each of the range, what we need to do is we need to choose a value from here and then we need to sub into this expression here to check whether the value is positive or negative. Right? So example, let's say I choose negative 3 from this range and then I sub into here. So I don't need to calculate what is the answer when I sub into the k. What I need to know is just, is it positive or negative? right? So let's say negative 3, negative 1 means negative 4, which is negative, and then negative 3 plus 2, which is also negative. So negative, negative, positive, right? The second range, let's say I choose 0 and I sub into this expression here. So if I sub here, it will be negative, sub here will be positive, so negative, positive, negative. Then for the last range here, let's say I choose 2. So when I sub into here, 2 minus 1 here will be positive, 2 plus 2 here will be positive. So positive, positive, positive. Okay, so once we have found whether it's positive or negative, we can look at our condition here. So here our condition is must be greater than or equal to 0. This means it must be positive. Alright, so here our answer would be these two range. Okay, and then I can write out a final answer. So k is less than equal to minus 2 and k is greater than or equal to 1. Last question coming from trigonometric functions. So here we have a trapezium and we need to derive one basic identity which uses tan theta and secant theta. Right, so as you may know, there are some formulas which are called basic identity formulas, which is these three. So the one that involves tan and secant is formula 30. So this question actually tells us from this trapezium, want you to prove this formula. Right, so how do we do this? Okay, so I guess a lot of students will not be able to think from this trapezium, how do I get this formula? Right, so instead of trapezium to the formula, why not we think the other way around first? From the formula, let's, in some way, let's see does it relate to this trapezium. Okay, so in the diagram, this theta actually is inside the right angle triangle. So it's possible that we can find the tan theta and secant theta here. Okay, but here we don't have the length, so we need to find it ourselves. So this one is A, and the one at the bottom is B. Okay, so tan theta, okay, we don't need to look at the square first because the square later on we can take it out. Okay, so tan theta here would be opposite divided by opposite divided by adjacent, which is B over A. Right, so here I can change this tan theta to become B over A and then the square put outside. Secant theta, as we know, it's the inverse of cos, right? So it should be 1 over cos. So here we have a square, so I need to put the square here. So from this trapezium here, the cos theta is actually adjacent divided by hypotenuse, right? So it's A over C square. So this denominator here is a fraction. Let's move it on top, right? So meaning we change the places of C and A. So here will be C over A square. So now you can compare these two functions, right? Both of them have this A at the denominator. So for the one here, we can do it the same thing as well. We change the denominator to become A. And we add the square here. Then because the answer here is 1, so here should be itself, right? So A over A, which is 1, and then 1 I square, then I get back the value above, right? So now, as you can see, they have a similarity already. All values divide by A. Okay, then for the square here, let's multiply inside. Right, once we put the square inside, I still cannot relate this equation with the trapezium here. So what we can do is we simplify even further. So since all of the fractions, they have A square, so why not we multiply both sides with A square, right? So A square, then we can cross off all the A squares here. So at the end, you'll get C square equals to A square plus B square. This is actually the Pythagoras theorem. Okay, let's go back to the trapezium here. So A and B is the straight lines. C here is the hypotenuse. right? So a square plus b square would be c square. So to prove this equation, actually it comes from the Pythagoras theorem, right? So now, since we know this, let's go from our answer here back to the top. So let's start off with the Pythagoras theorem. Okay, then later on, for each of the values we divide a square, because just now we multiply a square. Then for each of the values here, let's change back to the 1 tan square theta and secant square theta, right? So this one will become 1, this part will become tan square theta, this part will become secant square theta. Okay, and that is how you prove the basic identity formula. Alright, for the next part, we need to solve this equation and make sure that x is between 0 and 360. Okay, so for the first step, we need to make sure that our equation here has only sine or cos, right? Because from the 6 functions that we have, right, everything actually comes to sine and cos. For example, tan, it's actually tan equals to sine x divided by cos x. So everything will go back to sine and cos, as it will help us to simplify the equation much easier. Okay, so for the secant 2x here is the inverse of cos, right? So here should be 1 over cos 2x, and then we move it to the right side. Okay, now going back to the formula sheet, we have 3 expressions for cos 2x. So which one to choose? Okay, so a hint is we need to make sure that the equation has the same function. Okay, so just now I said that we changed to sine and cos, but once we changed already, we need to make sure that the equation has only one function, one type of function. So here we can just look at the one that has the sine, because here we already have sine on the left side. So if we look at the equations here, only this equation has sine only. Okay, so why not we change this cos 2x to become this? Okay, then we can move it to the left side. So you can see that if we have all the functions to become one type of function, now you can see that we can form a quadratic equation, right? Because we have a square here, we have the sine x here, and this value doesn't have sine x. Okay, so here we can just factorize, find the two values of sine x, which is -1 and 1 over 2. Okay, so now we need to separately find the value of x. For our first case, sine x equals to -1, I'll consider this as one of the special values. So special values would be -1, 0, and 1 for sine and cosine graph. So why I consider this as a special value is because we need to go to the graph using the sine or the cosine graph to find out the answer. Okay, so let's say we are using the sine graph, and then we need to find where sine x equals to 0. So 0 meaning 0 is here. So we need to figure out which parts of the curve that intersect the black line. Okay, so as you can see, we intersect 3 parts. So it is here. So here the first degree will be 0. Okay, and then here is 90 degrees, so we will skip. This part would be 180, right? 180 degrees. Okay, this below part is 270, so it doesn't intersect, so we'll skip. Then we go to the last point, which is 360. So as you can see from this graph, we can able to find 3 answers straight away. But if we put this into the calculator, right, let's say this sine, I move it to the other side, arc sine. So sine -1 is called arc sine, ARC sine. And then we put -1, we put into a calculator, there will only be one answer. Alright, just one answer. So what we need to do here is to, instead of using the calculator, use the graph to find all the answers. Okay, so from here, if it's -1, means we are looking at this point. Okay, and the angle is 270, right? So our answer would be 270. Okay, for the second one, sine x equals to 1 over 2, this one we can use the ASTC graph. Right? So here, as we can see, sine and it's positive, so the parts where sine is positive is only A and S. Okay, so A would be theta, S would be 180 degrees minus theta. And this theta actually is the value if I move the sine to the other side. Okay, so based on the calculator, you will get 30 degrees, right? So this part we have found it's 30 degrees. So this one, for S, we need to 180 minus 30, right? To get two answers, one is 30 and one is 150. Okay, this one is 150, sorry about this. Right, so later on we just combine the two answers here to find our final answer. For part C, we are given these two equations, and from these expressions here, we need to write it into P and Q. Alright, so one of the equations actually is two angles minus together. So according to the formula sheet that we have a few formulas which does this, right? As you can see here, A plus or minus B for all. So here we are looking at cos, so we should look at formula 36. And if we compare the equations that we have with the formula here, actually there are a few parts which are similar. So let's assume that A is x and B is y. So this cos x minus y here is actually similar to this part. This sin x sin y is similar to this part. And for part 1, cos x cos y is actually this part. So now we can use this formula to help us find cos x cos y. So what we need to do is just for so here I change from A to x, B to y. So here I can substitute this part into here. Okay, and the cos x cos y. Oh, and also to make sure that the sign is correct, yeah, because here we are using minus. So according to here, if I use minus, here should be plus. Okay, so here should be plus. Make sure that this sign is correct. A lot of students will make the mistake, which they will put minus. Right? So once I simplify, then we can get the final answer, which is P over Q minus Q. And for part 2, okay, so this one is straightforward. We should just straight use back the formula here. Okay, so cos x plus y and then the cos x cos y, and we need to make sure now it is minus, yeah, okay, because here positive, up here is negative. Okay, negative, and sin x sin y. So cos x cos y just now we have gotten in part 1, which is this one, so we can just substitute inside, and this sin x sin y will be Q. Okay, so to simplify, you'll get your answer, P over Q minus 2Q. And with that, we have completed the discussion for this paper. Right, so thank you so much for watching this video. If you have any questions regarding this paper, feel free to put in the comment section below. So now I'll flash through the answer key for all of the questions. So again, thank you so much for watching. Take care, and I'll see y'all in the next video. Bye bye.